Mounting a motor. Today we're going to mount a motor. Basic motor, fixed, nameplate saying it's basically 1/3 horsepower, 0.33, fractional single-phase motor. In mounting a motor, we start off with a bed plate. The surface considered to be your lab table is a bed plate. It's fixed. It will not change positions. It is what we mount everything to relatively. It will keep all of our driven, our load, and our driver, the motor, connected together in a fixed position. We'll start off with the motor with what's called risers. First of all, we put the motor in a position that we desire it to be, roughly aligned with these 4 slots. The front two, leaving the back 2 over to the end of the table alone. So that we'll mount the motor mounting holes, 1, 2, 3, 4, with the motor shaft pointing towards the long part of the table. We will mount this on top of risers. Motor risers, circular discs. And for purposes of this layout, we will first talk about softwood using the aluminum risers. There should be 3 of them, as you see by hand, and a brass riser, which we'll find out shortly enough will be slightly thinner than the aluminum to show softwood. Start off by mounting the motor with risers underneath the motor. On the back side, we'll put 2 more in addition. Then all holes will be connected through with a 5/16 bolt, 5/16 diameter, number 18 pitch, 1.5 inches long, should look like this. We will need 2 flat washers, both with clearance holes for 5/16. Flat washer inserts, through hole, a 5/16 lock washer, in this case is called a split lock washer. You see the split right there as opposed to star washer. There's just enough clearance for this to fit upon the bolt. And finally, a 5/16 hex nut, able to go on the bolt itself and thread on. It is highly recommended to try out all components of the system first. Taking apart bolt, flat washer, lock washer, bolt, and screw in. By screwing in, we assure ourselves that the bolt is not stripped, the threads are not stripped, and that the hex nut itself is not stripped. If the hex nut can go on at least as far as fully on in that position, then the hex nut is okay, but for the threads on a bolt to be checked, should be screwed on to just about the full length. You should have 4 sets of these in order to put into the mounting holes. Now to drop the bolts into the holes. I've already mounted 3 holes. The 4th hole, we take one of the 5/16 bolts, 1 flat washer for the head, drop it through the slot, the riser underneath, and the hole in the table, which is a slot actually. Drop that down, and from underneath we're going to put in order going up, flat washer. Going out from underneath, we're going to add the flat washer, then a lock washer underneath, then finally the hex head. And these we put on by hand, usually finger top on the head, flat washer from underneath, and this is by feel, lock washer, and using the hex nut, and we will hand turn the hex nut, not quite hand tighten. The feel you should have is that we can feel it make contact, but it's not tightened down, not even hand tightened yet. The reason why is we want to be able to check for our next step, which is checking for a soft foot. Now, soft foot's a condition like on table legs, when you have one table leg too short and the table tends to rock back and forth as you lean on one edge or the other. Motors have the same problem with bed plates. So one of the things we will do is check for that condition. And right now I'm rocking the motor back and forth, and you should be able to see here a slight movement. That's referred to as soft foot. That soft foot is not an allowable condition. And so what we have to do is determine how much to shim or lay material underneath so that all the riser plus the shims and the bed plate are exactly the same height for the motor mount so that the motor sits flat and tight. Now, in order to do this, the preferred way to do this is to recall our old friend, the feeler gauge. And in feeler gauges, our typical specification is that if we can slip about 0.003 underneath any one of the 4 feet comfortably, then we have a soft foot condition to be corrected. We are allowed about 0.02 of an inch. So we try out our 0.003, very flexible, underneath our foot, and as you can see, I can slide it in rather easily. No trouble at all. In fact, it still rocks. That means we have a soft foot condition. Now, on the feeler gauge, we can go much higher. I'm going to pick on the first one I see is a 0.024. And a 0.024 doesn't quite slide. You can see it's flat there. Slide underneath the foot. So it's not quite a 0.024 condition. Now, in order to get to this, basically it's a trial and error, and you can use basically binary search method, whatever, to determine which one to use. In this case, I will go to, after doing a little bit of searching through basically a lot of feelers, at a 0.019 feeler, I can just about slide this under. There it goes. And no rocking at all either way. But I can just barely get that under comfortably. So it's about a 0.019. I would even try a 0.018 in this case. Leafing through. 0.018. And bringing that riser out. That does go through rather comfortably. So this is the shim choice 0.018. Unfortunately, we normally don't have 0.018 shims. What we do have in shims is several 0.003s. There's a little embossed 3 here. Very, very flimsy and thin, paper thin. We have, as you can see here, a 0.005 shim, 0.005 of an inch, little stiffer. We also have a 0.010 shim, much stiffer. Now to get to 0.018, just like we did with the level, 0.010 plus 0.005 plus 0.003 equals 0.018. Remember, it's 10 plus 5 plus 3 equals 18. And I take the stack of 3, put them together in one shape, and we will slide now this collection underneath, between the bed plate and the riser is where we'd like to be with it, and we'll slide it out so that the bolt underneath catches into this slot. So now I proceed to push it in. Make sure you got all 3 shims there. You see all 3 shims? Now when I attempt to rock this by hand, it no longer rocks. That is what we're looking for there, and that corrects the soft foot. Now what I have to do is to hand tighten, finally, and do it diagonally, good torque pattern. So if I do this bolt first, I'll do the diagonally opposite bolt next, and hand tighten. It's okay to use a wrench if you want to go around the head. Incidentally, for 5/16 wrench, or 5/16 bolt, it's about a 1/2 inch wrench. 1/2 inch for the hex nut, 1/2 inch for the head. And I'll catch this last bolt in behind. And we have got our motor mounted on risers, soft foot corrected.